introduce fourth example of SimPy simulation. Before introduction of the actual example, we are going to review and some details about process interaction in SimPy simulation. There are three kinds of process interaction could be implemented. First one is the sleep until an event is triggered. It means woken up by using the passivate or reactivate. But this command is not used anymore in SimPy 3. These were used until the SimPy version 2. So the second one is waiting for another process to be finished. And third one is to interrupt another process by using the interruption event. Let's see the simple example of electric cars. You can download this example at the topical guide. I will type this at the chatting window. You can refer and download this code at topical guide at SimPy documentation website. Now let's imagine you or any one of you want to make a model, an electric vehicle with a very, very intelligent battery charging controller. While the vehicle, the car is driving, the controller can be in the state of passive, but it has to be reactivated as soon as the car is connected to the power in order to charging the battery of the car. In SimPy version 2, the passivate and reactivate the function was required for waiting a certain kinds of condition. But in SimPy version 3 that we are currently using, but also including the version 4, we don't need to use passivate and reactivate function because the same behavior, reactivated or passivated, can be implemented with a normal event, the SimPy shared event. So you can make a model successfully with a simply by use of shared event that is coded here. The battery controller reactivated variable is defined as the shared event. However, this example has some problems. It means that it may happen that the car or vehicle wants to park for a shorter time than the time that takes to charge a battery. For example, if the charging time is being created as about charging time is 90 minutes, but in this example, the parking duration, if the parking duration is generated as 60 minutes, in this case, cannot be created in this example. Let's see what is happened in this example. There is a two function. First one is drive, and second one is battery, the controller. And these two functions may be started simultaneously. at the point of time that is simulation is run. In terms of the drive function, that is the drive time is generated by random init function between 20 minutes and 40 minutes. Also, the battery controller function is be started at the same time. But in this case, this battery controller will be the delayed status here by yielding this event, battery controller reactivate. And this generator will be triggered when this function is being activated. It means that if in drive function, this battery controller reactivate event, this is the shared event. And by using this succeed function, this generator will be triggered. And as soon as this function is triggered, the battery controller will be started. So it's simply noticed by printing this phrase with the simulation current time. And the parking time also be started at this point between 60 minutes and 360 minutes. It's between 1 hour and 6 hours. So in this example, cannot reflect the status of the shorter parking time compared to the charging time. So this problem can be resolved in this example by using the process interaction. This is a little bit more simple compared to the reactivate and passivate. It means that the only use the shared event. In this example, new battery controller function will be started every time the electric vehicle starts to park. That point is here. When this vehicle have some driving of time between 20 minutes and 40 minutes, after the driving, this car will start to park. And in the time, at the point of a time that parking is started, in this drive function, the battery controller event, the process is being triggered here. So at this point, the parking process is being started here. Also, the controller event is also triggered here with the different time. This different time is created. So in terms of the car, it means that in drive function, by yielding the charging and parking, and by using the ampersand, this means that and condition. So in this point, this car have to wait until the both process will be finished. So in this example, this vehicle can wait until the longer event. So in this example, the both case can be reflected. Both case means that one is that the longer parking time compared to charging duration. Also, the charging time can be longer compared to the parking time. So this example is the process interaction is more flexible compared with this example, only using the shared event. But in this example also has some limitation. If the trip is very urgent, it means that this car have to start to drive before the completion of the charge. But this example cannot reflect that urgent driving case. It means that in this example, we always need to wait until the battery is fully charged. So the answer for this problem is to use the interrupt that we have already studied in previous example. And actually, all of you may be very familiar with the use of interrupt, but let's see again briefly this code. It's called the default structure of this code is very similar with the previous one, but only the interrupt function is this interrupt function is added to this example. And also in terms of the battery controller, there by use of try and except, this interruption can be included in battery controller. So when the charging dot interrupt is being triggered, then this battery controller event, that point is here. So in spite of the not finished status of this timeout can be interrupted by use of this except and SimPy interrupt. And this interrupt is being triggered from this point. Okay. Everybody can get understood? Okay. Now let's see today's example, that is movie renege. And this example is a little bit complex compared to the previous ones. Now, the summary of this problem is like this. This example make a model of movie theater with only one ticket counter and selling tickets for different three kinds of movies. And people are arriving at a random time, and each customer is trying to buy a random number of tickets for a random movie. Also, when a relevant movie that the customer wants to buy is being sold out, and all people waiting to buy a ticket for that movie will be reneged. It means that the customer will leave the waiting queue. The movie theater, in this example, the movie theater is being defined as a kinds of controller. In this example, we will use a named tuple object that is belonging to the collections package in Python. And by use of named tuple for all the related data. The related data includes movies, counter, the number of tickets, those are remained, and etc. And the counter may be defined as a resource object in this example, and with a capacity of only 1. So let's see some animation. Each people is arriving at a counter with a random movie and random number of tickets and consumes the random number tickets. And next people, and he wants to see Iron Man, and next people wants to 7 tickets of Captain America, but they're Captain America, and next people wants to buy 6 tickets of Iron Man, but there is no 6 ticket, so unavailable. He may leave the queue, and in this way, the simulation have to be conducted. So let's summarize the process of the simulation. The people, in this example, this people is called as moviegoer. And moviegoer process starts waiting until the ticket counter is available, or until the wanted movie is being sold out status. And if the movie that the customer wants to see is being sold out, then these people will leave the theater. And if there is a remaining tickets, these people is going to the ticket counter and tries to buy some tickets. And if there remains enough tickets, these people consumes the number of tickets that he or she want. And if in case that the remaining tickets are smaller than the people wanted, then in this case also the people have to leave, or it means the renege, and he or she may leave this theater. And in this example, there is 2 random variables. First one is inter-arrival time, and second one is the service time. So the reason why that this example is a little bit complex is because there are various of the attributes that have to be implemented in theater object. So now let's see the entire code of this example. This is the animation, so wait a moment. I will go to the full screen mode. Okay, let's see the internal code. We need to import collections packages because we have to use named tuple variable in this example. And there is 2 global variable. First one is the number of tickets of each movies when the simulation is started. And simulation time is being defined as 120 maybe minutes or hours. Anyway, there is no units, only the simulation time units is 120. And here the theater object is defined as a named tuple of collections. And in the named tuple can have the key, and also this named tuple can be triggered by use of index. So this is very flexible object in Python. And here the named tuple with the is a key variable theater, and there is a counter as a resource, and the kinds of movies and the number of tickets those are available. And this sold out will be implemented as a shared event in this example. And this variable will store, it means to save the time that all the tickets are sold out. And also the number of reneges will be saved in this variable. And here, let's see, this container or container shape is like this. And by defining each internal variable of named tuple with this part. First one is counter. Counter is a SimPy resource object that will be stored in this named tuple variable. And also the movies will be stored as the array or list. There is 3 movies: the Unchained, Kicker Process, and Purple Implementation. Those are the name of the movies. And these movies will be stored here. And available variable is being, this is a dictionary variable as a key with a movie name. And each movie, it means that each key with the name of a movie will have a number of tickets that is defined here. So by defining this available variable as this kinds of dictionary, each movie has 50 tickets in the start of the simulation. And next one is sold out. Sold out also defined as a dictionary variable with a key variable of the movie name, and each movie with respect to each movie name is related with the shared event. It will be created here. And by use of this shared event, the people can track the availability that he or she can buy the ticket or not. And also the when sold out variable is also defined as a dictionary variable. And in this variable, the time when the relevant tickets, relevant movies ticket is sold out. And also the reneges of with respect to each movie will be saved in this dictionary variable. And finally, the theater variable is created here with the predefined the resource, the array variable, and four numbers of the dictionary variable. Is it okay? Everyone is following the explanation? 영현이는 왜 웃어? 재미있어? 자, okay. By use of the named tuple variable, we can define this kinds of object. So it is very, very flexible way to make a very complex structure of the data and the information. So now we defined the most complex part of this example. So go to next part. In this example, there is a two function. First one is the customer arrival, and second one is moviegoer. And in the body of the simulation code, the process is being triggered from the customer arrival function with an argument with a theater variable that is defined in previous slide. Now, in this example, there is the main two branch. Those can be activated. So that branch is splitted at here. So now let's see the first branch. Anyway, this customer arrival is being repeated with the inter-arrival time of what was the inter-arrival time in the problem? I cannot remember. Wait a moment. That is 0.5. 0.5. I think that it may be 0.5 minutes in this example. And because we use the export evaluate random function, so we have to take a reciprocal number of the errors inter arrival time here. And in this line, we are randomly choosing the kinds of movies. And by use of this .movies member attribute of the theater variable, we can choose the kinds of movies in random way. And that chosen movie name is stored to this variable. And also in here, the required number of tickets is also created in random number between 1 and 6. So in this part, if the required movie is available, it means that we have seen available is the number of tickets, those are remained. So in this part, if the number of remaining ticket is not 0, then this movie goal process is triggered. Okay. But if there is no tickets remained, it means that this member attribute, the available, equal to 0. This part is not conducted, triggered. So first branch is the case with the positive number of the remaining ticket. So let's assume that there is the more tickets are remaining with respect to the chosen kinds of movie here. So this movie goal process is being triggered. So go to the movie goal process. Now, let's see the movie goal process with argument of kinds of movie and the required number of tickets, and also including the theater, the named tuple variable. And by use of the with and request, in this part, the movie goal will wait until the counter, the ticket counter is available. So in here, by editing the generator with 2 conditions. First one is my turn. That is the generated by the request of the resource. And second one is the sold out event of the relevant movie. So let's see the case of the available. It means that the ticket counter is available. By editing this my turn event, this line goes to here. This part is being skipped because if my turn not in result means that in this result, by generating this eld function, if there is not my turn in result variable, it means that this part is being firstly the upcoming. It means that there is no more tickets. Those are remaining. Can you understand why this part is being located here, not here, not in here? Because this whole structure is being progressed iterative way. So during the creation and waiting of a certain movie goal, the other means that previously the arrived customer can be in status of trying to buy a ticket with the same movie. So during the waiting of the ticket counter, the relevant movie, the number of tickets of a relevant movie can be sold out. So in this part, this moviegoer have to be status of that he or she have to choose between these two events by not he or she's will. It is being forced by the status of the previous customer. So that is the reason why the theater that sold out events is located here. Okay. So let's assume that there is the relevant movie's ticket is not sold out. So this part will be skipped. So let's go now. This part is skipped to here. So now check the number of tickets. If the remaining tickets is bigger or smaller than this compared with the number of tickets that moviegoer want to buy. That is this part. If there is not enough ticket that this moviegoer wants to buy, in this case, this moviegoer have to leave after some discussion. Maybe he or she can ask to counter, then ask about the other kinds of movies, or when he or she can see his or her wanted movie, or any kinds of conversation. And by assign this return, this function will be finished. But if the number of tickets that remain is bigger than the required number of tickets by moviegoer, then he or she can buy tickets here. So the available number of tickets of relevant movie will be decreased to a certain number by subtracting the number of tickets. And in this part is very important, because in this part, in this ticket counter, you have to decide about the triggering the sold out event for the relevant movie. So if the remaining ticket, the number of remaining ticket is smaller than 2, in this case, the number may be 0 or 1. In this case, the sold out member attribute of the theater is being triggered. Do you remember what kinds of variable is of this sold out? This is the shared event, and this shared event is being succeed. That means that with the relevant movie, the sold out event is being triggered permanently until the completion of the entire simulation. Okay, so by succeeding this event, this movie is not available anymore. So this sign, the sold out sign, will be appears in some signboard of the counter, can be shown in the counter. And also the time that the relevant movies tickets are sold out will be saved with the environment.now time. And the available number of ticket is changed to 0. I don't know why even though there is in case of the one ticket remains, but in this example, even though there is tickets, one ticket is remaining, but in this part, the available ticket number is set to 0 in this part. This is the one branch of this simulation. This branch means that the moviegoer can buy his or her tickets and check the remaining ticket. And if the number of remaining ticket is smaller than 2, then sold out events is being triggered and change it the number of this variable available number to the 0. If this number is set to 0, in this part, this moviegoer cannot enter the ticket counter anymore in this part. Now let's see the another branch. Another branch is here. If in this part, the available number of tickets with the relevant movie is changed to 0, and next customer who wants to see the randomly chosen movie here, and if the number of this available variable is 0, then in this part, this simulation cannot the process of this moviegoer cannot process anymore here. Also, if in this part available number may not be 0, so this moviegoer process is triggered successfully, but during the waiting of the counter here, if the previous customer who is trying to buy a ticket of the same movie with this moviegoer, and he's trying to buy the same movie tickets, and by trying to buy this behavior, and the number of ticket can be changed to 0. And in this case, this sold out event is being succeeded. So in simple way, during the time that this moviegoer is waiting here for the counter, and during this period, if another customer is trying to buy a ticket and the status is changed to the no remaining tickets and the sold out events triggered, then this moviegoer is generated with this event before the ticket counter available of ticket counter. Okay. Am I explaining in the right way for your understanding? So this is the whole structure, and finally is the the result analysis here. Actually, in this part, we already saved the sold out time here. So we can print out the time that the sold out moment of each movie here. And also we have saved the renege numbers here. Okay, so we can print out the number of people who have left the theater by printing out these num_renegers of the relevant movie. Now, let's run the actual code. You can download this code at the SimPy documentation site. I will start the simulation. It's being processed very quickly. Let's see this part firstly. Let's see the theater here. You can see here the theater variable. It named the tuple here. Here, inside of this theater, there is a counter that is a SimPy.resource object, and the list variable movies. It contains 3 names of each movies, and in available variable, this is the dictionary type. So by use of the key as a name of each movies, have the relevant number of tickets, those that remains. Those are all 0 because this is the state of the end of the simulation. And also, let's just say sold out. Also, sold out is the dictionary type variable. So there is a key member here with the name of.
안 나오고 있습니다.
안 나와? 아, 나 혼자 떠들고 있었네. I'm sorry, I will start again. What I have done is just run the simulation. It's being finished very quickly. You can see here the final analysis result. And let's just see the variable here, the theater. This theater variable is defined as a named tuple, and inside of this named variable, first variable is counter, and that is defined as a SimPy resource like this. And next variable is movie, and this movie variable is defined as a list with the name of 3 movies. And available is defined as a dictionary variable. So as a key with the name of the 3 movies, and with respect to each movie name, there is a number of remaining tickets. And this is a status of the end of simulation. So there is no more tickets is remaining. And sold out variable is also defined as a dictionary with a key variable with the movie names. And we cannot the meaning of this variable, but this is the internal ID of the shared event. So there is a 3 independent event with respect to each movies. And when sold out is also defined as a dictionary variable and with a key variable as the movie names. And the sold out point of time is saved like this. It's 3. And number of renegers is saved also as a dictionary variable with the final number of like this. Okay. You can check the type of each variable movies as a list, and number of renegers, counter, available when sold out, also is shown as a dictionary, and in case of movies, there is a list here. Okay. You can run this simulation by you can change the number of tickets, or you can change the simulation time. Also, you can change the interval time here. Also, the limitation of the number of the tickets that one moviegoer can purchase at a time.